The U.S. Navy did not build escort carriers because they were clever. They built them because American Marines were drowning, bleeding, and dying on beaches while perfectly designed carriers stayed safely beyond range. Every landing in the Pacific exposed the same brutal truth. Air power decided survival, but American air power could only stay overhead for minutes. When the planes left, men died. Slowly, predictably, repeatedly. Generals called it unavoidable. Engineers called it a limitation of range. But for the men on the sand, it felt like abandonment. The Navy faced a choice no institution wants to admit out loud: risk sailors at sea, or keep sacrificing infantry on shore. Ships they approved next were not meant to be safe. They were meant to be there. Dawn breaks over Tarawa Atoll, and the Pacific turns red. First Class Robert Sheridan crouches behind a shattered seawall, water up to his chest, rifle soaked, lungs burning. Around him, bodies drift in the surf. Landing craft are stranded on the reef 500 yards from shore while Japanese machine guns rake the open water with mathematical precision. Scream for air support. Fighters circle, but too high, too far, and already running out of fuel. They can stay minutes, not hours. When they peel away, the beach is silent, except for gunfire and screaming. It is the brutal arithmetic of island warfare. To take a single strip of coral, Marines must cross open water, breach fortified beaches, and survive long enough to push inland. That requires continuous air cover fighters to strafe bunkers, bombers to smash gun nests, spotters to guide naval guns. But America's fleet carriers are far offshore, kept at distance to avoid submarines and air attack. Planes burn half their fuel just reaching the battle. What remains is a cruel rhythm: 15 minutes of air support, then silence, then slaughter. Within 3 days, nearly 1,000 Marines are dead. The survival rate of the first wave falls below 30%. Commanders watching from offshore know exactly why, and they know they can't fix it. Carriers are too valuable to risk closer, too slow to replace, too few to cover every landing across the Pacific. His after-action report, Raymond A. Spruance writes with cold clarity, the lack of continuous close air support cost hundreds of lives. Marines dying on Tarawa don't know is this: 1,400 miles away, someone has already decided that the rules of naval warfare are wrong. An admiral, not a ship designer, not a man who has ever built a warship. And the solution he's about to propose will be laughed at, ridiculed, and officially declared dangerous. But it will change the war. The shock of Pearl Harbor changes naval warfare in a single morning. Battleships burn at their moorings, steel giants that once defined sea power sink in shallow water, but the true targets, the aircraft carriers, aren't there. By chance or fate, America's carriers are at sea. And within hours, every admiral understands the truth. The carrier now rules the Pacific. And America doesn't have them. In December 1941, the United States Navy operates just 7 aircraft carriers across 2 oceans. Japan has more, and worse, it has experience. Its pilots are veterans. Its carrier doctrine has already been tested in combat. America is entering a carrier war while already behind. Building new fleet carriers takes time the war will not allow. 3 years, 4 years per ship. Millions of man-hours. Shipyards already overloaded with battleships, cruisers, destroyers. Harold R. Stark, Chief of Naval Operations, faces an impossible equation. Carriers are needed everywhere, protecting convoys from submarines, hunting Japanese task forces, and supporting every amphibious landing across the Pacific. There are not enough hulls, not enough slipways, not enough skilled workers, and not enough time. Planners propose a compromise. Converted from merchant ships, slow, lightly armed, expendable. Fight enemy fleets. They'll escort convoys and provide limited air cover. On paper, they are a stopgap, a temporary solution to buy time until real carriers arrive. Navy's Bureau of Ships drafts cautious plans in mid-1941. A handful of conversions, slow testing, careful evaluation, maybe 10 ships by late 1943 if everything goes right. Doesn't satisfy anyone. Trust carriers altogether, let alone cheap ones. Internal memos are blunt. These ships are called death traps, too slow to evade submarines, too weak to survive air attack, too small to defend themselves. The report predicts loss rates exceeding 40%. Another admiral writes a single line in the margin, acceptable given their cost. The skepticism isn't just tactical, it's cultural. Real warships are built by naval architects in naval yards. These proposed carriers would be built in commercial yards by civilian workers, designed by engineers who've never served a day at sea. In the Navy, that makes them untrustworthy before they're even laid down. By May 1941, only one test ship exists, USS Long Island. It takes 8 months to convert. It's cramped, slow, and carries barely 20 aircraft. The verdict is lukewarm. Eat slowly, not slowing down. Japan controls thousands of islands. Every landing demands air cover. Every convoy needs protection. The math becomes undeniable. America does not need 10 escort carriers. It does not need 20. It needs hundreds. The rule of naval engineering, that is impossible. That's when the problem lands on the desk of a man who has never accepted the word impossible in his life. Next comes the outsider. The man who steps into the story doesn't wear a uniform. His name is Henry J. Kaiser, 60 years old, no college degree, no naval background, no experience building warships of any kind. His world is concrete, steel, and deadlines. Dams, bridges, highways, projects everyone else says will take a decade, and Kaiser finishes early. Engineers said the Hoover Dam would take 7 years. Kaiser finished it in 5. When critics called the San Francisco-Oakland Bay Bridge impossible, he delivered it ahead of schedule. Reputation isn't elegance, it's speed. In 1941, Kaiser reads reports about British shipping losses to German submarines and sees something others don't: a production problem disguised as a military one. Ships are being sunk faster than they can be built, not because engineers lack skill, but because shipbuilding is still treated like craftsmanship instead of industry. Kaiser does something heretical. Empty land in Richmond, California in 90 days. No tradition, no naval hierarchy, just cranes, rails, and assembly lines. He hires women, minorities, and untrained workers. He teaches them one task each and repeats it at scale. He welds ships together instead of riveting them. Old Navy men are horrified. Welds are unproven. Rivets are tradition. Welded ships are mocked as floating tin cans. But Kaiser's cargo ships launch in a fraction of the time, and they work. In 1941, Kaiser is delivering freighters in 110 days, less than half the industry average. When he tours a naval yard and sees something that stops him cold. A fleet carrier, USS Essex, still on the ways. Its keel was laid months ago. It won't be finished for nearly 2 years. Kaiser does the math in his head and understands the truth instantly. At this pace, America will lose the carrier war before it ever catches up. That night, he calls his chief engineer, Clay Bedford, and asks a question no one in the Navy has dared to ask out loud. Ask, could we build an aircraft carrier? Don't build warships, They build freighters. Not what I asked, Kaiser says. How fast? Bedford sketches on a napkin. If you took a merchant hull already under construction, stripped it, added a flight deck, maybe 6 months. Kaiser leans forward. Silence. Kaiser adds, is it possible? Bedford stares at him like he's lost his mind. It violates every rule of naval construction, every safety margin, every tradition. The Navy would never allow it. Kaiser doesn't care. But allow it, he says. I asked if it could be done. The answer isn't yes, but it isn't no either. And that's all Kaiser needs. If something can be done once, it can be done 100 times if you ignore the people telling you to slow down. Next comes the confrontation. January 1942, Washington, D.C. Inside the offices of the Bureau of Ships, Henry Kaiser stands alone at the end of a long table. Across from him sit admirals and captains who have spent their entire lives at sea, men who built their careers on battleships, armor thickness, and careful design margins. Men who believe warships are not manufactured, they are crafted. Has 12 minutes. No finished drawings, just blueprints with pencil marks still in the margins. The proposal is simple and absurd. Escort carriers. Build them all at once. Deliver 50 ships, 1 per week. Boom erupts. Cochrane, head of the Bureau, doesn't bother hiding his disbelief. Mr. Kaiser, it took us 8 months to convert USS Long Island. You're proposing 50 ships in 50 weeks. Correct, Kaiser says calmly. Robinson leans forward. Have you ever built a warship? Sir? Arresting gear? Aircraft elevators? Sir. Hands. Then what qualifies you to do this? Kaiser doesn't raise his voice. I deliver what I promise when I promise it. The objections come fast. Submarines. No armor. Built to merchant standards. Welded hulls. Civilian labor. Memo calls the ships structurally unsound. Another predicts 30 to 40% loss rates. One admiral says the quiet part out loud. These vessels will be coffins. He listens. Then he asks a question no one answers. How many Marines died because we didn't have air cover? How many convoys have we lost because fighters couldn't stay overhead? More silence. Papers. Kaiser says, or 300 my way. Meeting ends badly. Stamped, confidential. Recommendation, do not proceed. Tactically unsound, operationally dangerous. Lose. If that report goes somewhere else. The Oval Office. D. Roosevelt reads it, sets it down, and looks up at Harold R. Stark. Explain to me, Roosevelt says evenly, why we're saying no to 300 aircraft carriers. Stark hesitates. He talks about standards, survivability, risk. Roosevelt cuts him off. Losing the war now. I don't need perfect carriers in 1945. I need carriers in 1943. Weeks later, the Navy returns with conditions. Naval architects will oversee design. Inspectors will monitor every stage. The first ship must pass sea trials before the rest are approved. He agrees instantly. He doesn't negotiate. Because now the impossible has become official. Next comes the part everyone said would fail: actually building the ships. April 5th, 1943. Exactly 11 a.m. Kaiser Shipyard in Vancouver, Washington. A bottle of champagne shatters against bare steel. Hull number CVE 55 begins to move. Slowly at first, then faster. First of Kaiser's carriers slides down the ways and into the Columbia River. Her name is USS Casablanca. To launch, 108 days. Navy's industry standard for a carrier, 350 days. Men who predicted structural failure watch in silence as the ship settles, stable and level, riding the water like she belongs there. No cracks, no buckling, no disaster. Floating is the easy part. Washington coast, the real test begins. He is rough enough to make skeptics hopeful. The flight deck is short. The ship rolls in moderate swells. Navy inspectors line the rails with notebooks ready to record failure. Single aircraft taxis forward an F-4F Wildcat. Lieutenant James Webb advances the throttle and lifts off the deck. Months later, he returns. 75 knots. Deck pitching. Arresting wires unproven. Hook catches the third wire cleanly. 6 more launches. 6 more recoveries. Systems hold. Arresting gear survives the strain. Thing that couldn't possibly work does. The loudest critics of the program submits a report he never expected to write. Against expectations, the vessel performed all carrier functions successfully. Recommend proceeding with full production. Floodgates open. 3. Kaiser is launching 1 escort carrier every 8 days, 50 ships in 14 months, the fastest carrier construction program in history. Still mocked, still called expendable, still known as Woolworth carriers. But in November 1943, Marines storm another Pacific beach, this time with escort carriers sitting just miles offshore. Bombers arrive every 10 minutes. Bombers return again and again. When troops call for air support, it answers. Casualties fall, momentum changes. Become permanent fixtures of every major landing. And when the war reaches its most desperate naval moment off Samar in 1944, these same cheap carriers will face battleships and refuse to die quietly. Began as an industrial gamble, becomes a strategic revolution. America didn't win by building the perfect carrier. Fast. The men fighting below, those floating airfields meant the difference between being abandoned on a beach and making it home alive. The story of America's floating airfields, the escort carriers of World War II, is not just a tale of ships and steel. It is a strategic lesson about how modern wars are actually won, not by the most elegant design, the strongest armor, or the most advanced technology, but by speed, adaptability, and the willingness to accept calculated risk. Before World War II, naval thinking was dominated by an old belief. Victory at sea belonged to the biggest and most powerful platforms. Battleships and fleet carriers were treated as masterpieces of engineering. Each one took years to design and build. In peacetime, this logic made sense. In a total war, it became a deadly liability. Exposed that reality with brutal clarity. American Marines did not lack courage or skill. They did not lack aircraft. What they lacked was continuous air support. Fighters from fleet carriers could only remain overhead briefly before fuel forced them to withdraw. Every gap in air cover translated directly into casualties on the beach. The problem was not firepower, it was presence. Leads to the first lesson. In modern warfare, continuity of force can matter more than absolute strength. A weapon or system that is always available, always nearby, and always responsive, can save more lives than a more powerful system that appears only intermittently. Escort carriers were weaker than fleet carriers in every technical sense, but they stayed close to shore. Their aircraft did not disappear after 15 minutes. They came back again and again. The second lesson lies in industrial thinking. Henry Kaiser did not invent aircraft carriers or naval aviation. What he changed was the way America thought about producing war. Traditional naval construction treated each ship as a unique creation, built slowly by skilled specialists. Kaiser treated ships like industrial products. He broke construction into repeatable tasks. He used welding instead of riveting. He prefabricated sections inland and assembled them like components on an assembly line. This shift produced a crucial insight. In total war, production capacity often outweighs technical elegance. A carrier that is good enough and delivered in 100 days is more valuable than a perfect carrier delivered in 1,000 days, especially when men are dying every week without air cover. Time itself becomes a weapon. Kaiser understood that every delay on the factory floor translated into bloodshed at the front. The third lesson is about risk specifically, risk that is acknowledged rather than denied. The U.S. Navy knew escort carriers were vulnerable. They were slow. They lacked armor. They could be sunk by submarines, bombs, or surface fire. Predictions of 30–40% loss rates were not fantasies. They were realistic assessments. The program went forward. Risk was not measured in ships lost, but in lives saved and missions accomplished. Even if an escort carrier survived only months or weeks, its constant air support during amphibious landings could save thousands of infantrymen. When framed that way, the so-called dangerous ship became the more humane option. Accepting the risk of losing ships reduced the certainty of losing soldiers. Leads to another uncomfortable lesson. Perfection can be immoral when time is short. Waiting for the safest, strongest, most refined solution may cost more lives than deploying an imperfect solution immediately. Escort carriers embodied that moral trade-off. The fourth lesson concerns morale and human behavior. On paper, escort carriers should have collapsed when confronted by superior enemy forces. At the battle off Samar, they faced battleships and heavy cruisers that outmatched them in every measurable way, and yet they fought. Attacked even when out of ammunition. Aircraft made repeated dummy runs to distract enemy gunners. Sailors fought fires, launched planes, and kept moving under impossible odds. The Japanese commander, shocked by the aggression, mistook these small carriers for a much larger force and withdrew. It reveals a critical truth. Humans do not fight according to specifications. Engineering sets the limits of possibility, but willpower determines how close those limits are pushed. A cheap weapon in the hands of determined people can produce effects far beyond what planners expect. Conversely, the most advanced system can fail if the people using it lack initiative or confidence. The lesson emerges from scale. Escort carriers were not meant to be permanent. Most were scrapped within 15 years of the war's end. They were disposable by design, but their disposability was a feature, not a flaw. They allowed the United States to apply pressure everywhere at once, covering convoys, supporting landings, hunting submarines, and freeing fleet carriers for decisive battles. Highlights a broader principle. Systems win wars, not individual platforms. Escort carriers were effective because they were part of a larger ecosystem. Industrial production, logistics, training, and doctrine all aligned toward the same goal. No single escort carrier mattered. The network did. The story delivers a lesson that extends beyond military history. In business, technology, and geopolitics, leaders often chase the perfect solution. They wait for better designs, better data, better conditions. Meanwhile, competitors move forward with solutions that are flawed but fast. World War II showed that adaptability beats elegance when the environment is changing faster than planning cycles. The United States won not because it built the best single ship, but because it built what it needed, when it needed it, in overwhelming numbers. Port carriers were born from desperation, not brilliance. They violated tradition. They offended experts. They accepted risks others found unacceptable. Yet they reduced casualties, stabilized operations, and helped turn the tide of the Pacific War. The ultimate lesson is simple but uncomfortable. Victory often belongs not to the side with the best ideas, but to the side willing to act on imperfect ones first. Sometimes, winning does not mean building something that cannot be destroyed. Sometimes, it means building something fast enough to matter and keeping it there long enough to save lives. At the beginning of the Pacific War, the United States possessed impressive tools: fleet carriers, capable aircraft, skilled pilots, and courageous ground troops. What it lacked was persistent presence at the decisive point. Amphibious assaults exposed this flaw mercilessly. Fleet carriers could not remain close to hostile shores. They were too valuable, too few, and too vulnerable to submarines and air attack. As a result, their aircraft arrived late, stayed briefly, and departed just as Marines needed them most. Purely technical perspective, nothing was wrong with the carriers or planes. From a battlefield perspective, everything was wrong. Leads to the first major lesson. A force that appears intermittently may be less effective than a weaker force that is always there. Air support that arrives every 10 minutes saves more lives than air support that arrives perfectly but rarely. The escort carrier solved a presence problem, not a firepower problem. Militaries often obsess over peak capability, range, speed, survivability. The escort carrier story reminds us that availability and responsiveness can outweigh raw performance. Power that cannot be applied at the right moment is wasted power. Traditional naval thinking equated quality with survivability. Armor, thickness, compartmentalization, speed, and redundancy defined whether a ship was good. Escort carriers failed almost all of these criteria. They were slow. They were lightly armored. They were built to merchant standards. They were expected to suffer heavy losses. In strategic terms, they were extremely high quality. Why? Because quality in war must be measured by outcomes, not specifications. An escort carrier that survives only a year but enables successful landings across half the Pacific is more valuable than a fleet carrier that survives the war but cannot be everywhere at once. Reframes quality as mission effectiveness over life cycle perfection. Escort carriers were not built to last. They were built to matter. The lesson is deeply uncomfortable for institutions that equate professionalism with refinement. But war does not grade on elegance, it grades on results. Henry Kaiser's true contribution was not a ship design, it was a philosophy of production. Before the war, shipbuilding was artisanal. Each hull was treated as a unique project. Changes were cautious. Testing was exhaustive. This mindset maximized reliability, but at the cost of speed. Kaiser treated ships like products, not monuments. He broke construction into discrete tasks. He accepted imperfect labor. He welded instead of riveting. He prefabricated aggressively. Most importantly, he built many ships simultaneously rather than sequentially. The result was not incremental improvement, it was exponential acceleration. This demonstrates a critical wartime truth. Production tempo can outweigh battlefield superiority. Escort carriers did not need to defeat Japanese capital ships one-on-one. They needed to exist in sufficient numbers to shape the battle space everywhere at once. Total war industry is not a support function. It is a combat arm. One of the most overlooked aspects of the escort carrier story is its ethical dimension. It's argued correctly that these ships would be sunk, and they were. Hundreds of sailors died aboard them. This raises an uncomfortable question. Was it moral to send men to sea on ships known to be vulnerable? The answer depends on how morality is measured. If morality is judged by ship survivability, then escort carriers were immoral. If morality is judged by lives saved across the broader war, then they were profoundly moral. Escort carriers reduced Marine and soldier casualties by providing constant close air support. They shortened battles. They prevented failed landings. They allowed momentum to be maintained. When compared to the alternative assaults without continuous air cover, the cost-benefit calculus becomes stark. It reveals a harsh wartime truth. Avoiding risk at the platform level can increase risk at the human level. Refusing to deploy imperfect solutions may feel ethical, but it can impose far greater suffering elsewhere. It forces leaders to choose between bad options. Escort carriers represent a choice to accept visible risk to save invisible lives. Naval analysts predicted escort carrier losses of 30–40%. Actual losses were far lower. This was not because analysts were incompetent. It was because complex systems defy linear prediction. Analysts assumed escort carriers would be used timidly, kept far from danger. In reality, they were used aggressively. Pilots compensated for ship vulnerability with audacity. Commanders exploited surprise, tempo, and confusion. Enemies misinterpreted their presence and strength. Off Samar illustrates this perfectly. On paper, escort carriers should have been annihilated. Instead, their unexpected resistance disrupted Japanese decision-making. The enemy commander faced uncertainty, not clarity, and uncertainty kills plans. The lesson here is critical. Enemy behavior is not static. Introducing a new system changes the opponent's psychology. Predictions based solely on technical matchups ignore human reactions, fear, hesitation, and misjudgment. Escort carriers succeeded not because they were strong, but because they changed the enemy's expectations. Another vital lesson is that escort carriers mattered not individually, but collectively. No single escort carrier was decisive. What mattered was the number of hulls provided, the logistics they enabled. They gave fleet carriers. They were nodes in a system, not stars of the show. Increasingly relevant today, distributed capability can outperform concentrated excellence. Many small, replaceable assets can create resilience that a few exquisite assets cannot. Escort carriers absorbed losses without collapsing the system. Fleet carriers could not. In modern terms, this is the difference between a brittle system and a resilient one. Perhaps the most enduring lesson comes from the people who fought aboard these ships. Others knew they served on cheap carriers. Pilots knew their decks were short, their protection minimal, their survival uncertain, and yet they fought with extraordinary aggression. Samar, pilots attacked without ammunition. They made dummy dives. They used their aircraft as psychological weapons. This behavior cannot be engineered. It emerges from morale, purpose, and belief. The escort carrier story demonstrates that human determination can amplify flawed technology far beyond its design intent. Conversely, technology without determination rarely performs to expectations. This is why the Japanese misread the situation. They saw the ships, they did not understand the men. Perhaps the most transferable lesson is the danger of delay. The U.S. Navy could have waited for more fleet carriers. It could have refined escort carrier designs. It could have insisted on higher standards. All of those choices would have been reasonable and catastrophic. Acting early with imperfect solutions, the United States seized initiative. It forced the enemy to respond to a constantly shifting operational picture. It denied Japan the ability to exploit American weaknesses. It applies far beyond warfare. In business, technology, and geopolitics, organizations that wait for perfect solutions often lose to those that deploy good enough solutions quickly and iterate under pressure. Escort carriers were iteration under fire. After the war, escort carriers were scrapped. No museums, no preservation campaigns. This was not neglect, it was consistency. Never meant to last. They were emergency answers to emergency problems. Their value lay in what they enabled, not in what they were. Not every successful system deserves permanence. Some solutions are temporary by design. The mistake is trying to make them eternal. The escort carriers teach a lesson that military professionals, engineers, and leaders resist instinctively. Victory often belongs to those who accept imperfection sooner than others accept reality. The United States did not win the Pacific War by building the best possible carrier. It won by building enough carriers fast enough to matter. Sometimes the right question is not, is this the safest solution? Is this the strongest design? Is this the most elegant system? Rather, will this save lives now? Will this change the battlefield today? Will this be there when it's needed? Escort carriers answered yes to those questions. And in war, that was enough. Escort carriers were not impressive on their own. They were slow, lightly armed, thin-skinned, and openly dismissed by professionals. Yet they worked not because they were strong, but because they fit perfectly into a larger, interconnected machine of production, logistics, doctrine, and decision-making. Those are not won by isolated excellence. They are won when every part reinforces the others. Military history is filled with wonder weapons, faster tanks, bigger guns, deadlier aircraft. Each promises to tilt the balance decisively. Most fail to do so. Japan entered the Pacific War with excellent ships, skilled pilots, and a highly trained navy. In many categories, Japanese equipment was equal or superior to American equivalents early in the war, yet Japan lost decisively. Without replacement is fragile. Fleet carriers, battleships, elite aircrews, these are assets that cannot be replaced quickly. When they are lost, the entire strategy collapses. Escort carriers inverted this logic. They were designed with the assumption that some would be lost and that it wouldn't matter. This is the first systemic lesson. A weapon that cannot be replaced is a liability, not an advantage. American engineers developed floating airfields during World War II by rethinking what an aircraft carrier was supposed to be and accepting ships that were good enough, fast enough, and close enough to the battlefield rather than perfect. How it happened, step by step. The problem: air power couldn't stay overhead. Early Pacific landings like Battle of Tarawa exposed a deadly gap in U.S. strategy. Carriers had to stay far offshore to avoid submarines and bombers. Fighters burned most of their fuel just reaching the beach. In short, unreliable windows. Casualties soared during gaps in coverage. Naval commanders knew the math. No continuous air cover equals massive infantry losses. 2. The radical idea: carriers that stay close, not fast. Traditional fleet carriers were huge. 3-4 years to build. Rule: slow is approximately equal to 18 knots. Built on merchant hulls. And for close air support, not fleet combat. These ships weren't meant to fight Japanese carriers. They were meant to be floating airfields parked 5-10 miles from the beach. 3. The man who made it real. Henry J. Kaiser. Kaiser wasn't a naval architect. He was an industrial builder, obsessed with speed. Approach: holes already in production. Weld instead of rivet. Higher sections inland. Run shipyards like automobile factories. Not one at a time. The Navy called his proposal reckless. Kaiser promised 1 carrier per week. 4. The ships, cheap, mocked, unstoppable. The result was the Casablanca-class escort carrier. Characteristics. Per ship, Wildcats and Avengers. Minimal armor. Built-in to 100 days. Sailors mocked them as carriers. Woolworth carriers. Iguala combustibly, vulnerably, expendably. Worked. Why they changed the war. Amphibious landings. Escort carriers provided. Continuous close air support. 15 minutes. Immediate response to marine radio calls. Casualties dropped 30–40% compared to early landings. They. Submarines. Lines. Freed fleet carriers for offensive operations. The ultimate test. Battle off Samar. In October 1944, escort carriers faced Japanese battleships. Overwhelming firepower in minutes. Instead, even without ammunition, aircraft made dummy dives to disrupt enemy fire. Faced fleet carriers. Enemy retreated. Lost, but the invasion survived. It was one of the most lopsided courage versus tonnage fights in naval history. 7. The real innovation wasn't the ship, it was the philosophy. The floating airfield worked because America accepted that. Speed of production mattered more than perfection. For armor, this could be saved by being present, not invincible. War is won by systems, not just weapons. Over 120 escort carriers served. And used them. Tens of thousands of ground troops lived because air cover never left. In one sentence, America surprised Japanese garrisons by turning cheap merchant hulls into permanent airborne shields, proving that fast, flawed solutions can outperform perfect ones when time is the real enemy. Want, I can. CTR YouTube script, act structure. Thumbnail power phrase, the plus thing plus twist. Extract image search keywords for editing. YouTube upload set. Tell me the next step. Sheridan crouches behind a shattered seawall, water up to his chest, rifle soaked, lungs burning. Around him, bodies drift in the surf. Landing craft are stranded on the reef 500 yards from shore, while Japanese machine guns rake the open water with mathematical precision. Scream for air support. And fighters circle but too high, too far, and already running out of fuel. They can stay minutes, not hours. When they peel away, the beach is silent, except for gunfire and screaming. It is the brutal arithmetic of island warfare. To take a single strip of coral, Marines must cross open water, breach fortified beaches, and survive long enough to push inland. That requires continuous air cover fighters to strafe bunkers, bombers to smash gun nests, spotters to guide naval guns. But America's fleet carriers are far offshore, kept at distance to avoid submarines and air attack. Planes burn half their fuel just reaching the battle. What remains is a cruel rhythm. 15 minutes of air support, then silence, then slaughter. Within 3 days, nearly 1,000 Marines are dead. The survival rate of the first wave falls below 30%. Commanders watching from offshore know exactly why, and they know they can't fix it. Carriers are too valuable to risk closer, too slow to replace, too few to cover every landing across the Pacific. After-action report, Raymond A. Spruance writes with cold clarity, the lack of continuous close air support cost hundreds of lives. Marines dying on Tarawa don't know is this. 1,400 miles away, someone has already decided